Hi there, Scott again from EdgeMath. I'd like to talk about discrete math subject today, graphs, in response to a question a student had. So there's some basic vocab terms. Let's see, I've drawn three examples of graphs. You can see we have vertices. Let's see, this graph here has 1, 2, 3, 4 vertices, the dots. So those could be, maybe they represent cities, or maybe people in a social circle, or could represent different things. But we've got the dots or the vertices, and then edges connecting some of them, or in this case we have edges going back to each vertex. So that's called a loop. And let's see this graph here, we've got 5 vertices, and then number of edges, it's like 6 edges. We've got this center vertex here, and then this graph also has 5 vertices, so, and then the 4 edges. So, and a basic basic vocab term is cycles. So a graph is a cycle. That means we can start at a vertex and then walk along edges and then come back to the vertex. So, like, for example, this graph here, there's a bunch of different possible cycles. We could start at this vertex and then go 1, 2, 3, 4 back, or this one. This graph here, let's see, here's a cycle, 1, 2, 3, 4. So we can start from this vertex and come back to it, or we can start from this vertex and find another cycle, 1, 2, 3, 4, 5. So we can come back along this route. But this third graph, it's pretty obvious that we can't start at this vertex and then walk along any edges and come back to it. So there's only one edge coming out of this vertex here. So we leave that vertex and there's no way to come back to it. So this one doesn't have any cycles. So that's a basic vocab term. There's no cycles here. So this is a tree. That's a basic vocab term. And then there's another possibility. If we can find a way to walk along every edge, if we find a cycle that goes through every single edge and then comes back to a vertex, that's called an Euler circuit. So for example, let's see, this one here, this one has an Euler circuit. So we can go, let's see, let's draw this out. We can start here, we can start this vertex, walk around, and go to the next vertex, walk around it, and there's the next vertex, walk around to this vertex, walk around, and then back to the original. So that's what we call an Euler circuit, because it goes through, we've got every edge covered, and it starts and ends in the same vertex. So this graph has an Euler circuit as shown. How about this graph here? Let's see. Does this have any? Let's see. We saw there's a cycle. You can start here. Start at this vertex. Go 1, 2, 3, 4. Come back to it. But is there any? Let's see. Is there any Euler circuit? Well, let's see. If there was an Euler circuit, then we would. Let's see. See if we would have to, every time we hit this vertex, for example, we'd have to come in and go back out, or come in again. So actually, there's an easy way to check if a graph has an Euler circuit. We just need it so every vertex has an even number of edges coming into it. So So if there's an even number of edges coming into every vertex, then we would have an Euler circuit. But for this one, there's no Euler circuit because, let's see, this one, for this vertex here, for there to be an Euler circuit, we would have to be able to go in, out, but here, let's see, if there was an Euler circuit, we could go in, then out. We'd have to, but then coming along the third edge, we'd be able to go into this vertex, but not leave it. So there's no way to have there's no Euler circuit for this one, because some of the graphs have an odd number, or some of the vertices, have an odd number of edges intersecting. So there's no Euler circuit for this one. So that's some basic terminology. So we covered vertices, edges, cycles. That's where we can start at a vertex and walk along edges, then come back to the vertex. And then Euler circuits, where we have a cycle that goes through every edge. We can even try for this one. Let's see. If we start here, then go here, here, here. Let's see. Trying to cover all the edges, we'd end up coming down here, then back to here. But there's no way to go back to the original vertex without going twice along this edge. So there's no Euler circuit there. And then a tree. A tree is, if a graph has no cycles, then that's what we call a tree. So great, that's some basic vocab. If you have any questions or comments, feel free to let me know, and have a great day.